Now let us see how to solve the problems to find the complementary functions and particular integral for an ordinary linear differential equations. So the first problem, solve d cube plus 1 into y equal to 3 plus e power minus x plus 5 e power 2x. So first step, we have to write the auxiliary equation. Put d equal to m and equate it to 0. So it becomes m cube plus 1 equal to 0. It is in the form of a cube plus b cube. So we are going to expand using a plus b into a square minus ab plus b square. That gives us m plus 1 into m square minus m plus 1 equal to 0. So m plus 1 equal to 0 gives us the root minus 1. M square minus m plus 1 equal to 0 is non-factorizable. Hence, by using the formula, we will get 1 plus or minus I root 3 by 2. 1 minus 4 is minus 3. So root of minus 3 is always I root 3. So it gives us an imaginary root. Thus, m is equal to minus 1 and 1 plus or minus I root 3 by 2. That is, the roots are minus 1, 1 by 2 plus or minus I root 3 by 2. So minus 1 is real and distinct. So we use case 1 of CF. Hence, we will get c1 e power minus x plus half plus or minus I root 3 by 2 are roots imaginary and distinct. Therefore, we will use case 3 of CF. That gives us e power alpha x. In place of alpha, we have half into. So, we are continuing with the constants. So, it becomes c e power half x c2 cos root 3 by 2x plus c3 sin root 3 by 2x. Now we are proceeding to find the pi. 1 by d cube plus 1 into 3 plus e power minus x plus 5 e power 2x. So whenever we have constants, we should write it in the form of e power 0x. And whenever we use case 1, e power x means case 1 of particular integral. So whenever we use case 1 of particular integral, denominator should be written in terms of factors. So we know that d cube plus 1 can be written as d plus 1 into d square minus d plus 1. And hence all the three terms are having e power x term. So we are substituting for d as m. M here for the first case is 0. In the second case, d is equal to minus 1. So when we substitute minus 1 plus 1 becomes 0. So there is 1 0 factor, but however the next one d square, that is minus 1 whole square, is 1. Minus of minus 1 becomes plus 1 plus 1. Thereby here we have minus 1 plus 1. 1 0 factor is there in the denominator. Hence we have to use the formula e power mx by phi of d x power r by r factorial, where r is the number of 0 factors. So here we will get, and the third one we have 5 into e power 2x by substituting d as m. We are not getting any 0 factors, so we can proceed in the same way. So we will get 3 into 1 by 1 plus e power minus x by 3 into x by 1 factorial plus 5 by 3 e power 2x into 3. Simplifying, we will get the particular integral, and y should be written as CF plus PI, that is CF as we wrote earlier plus PI. Hence the solution. Now let us go on with the next problem. Solve d square minus 2d plus 5 into y equal to sin 3x. So we have to write the auxiliary equation, m square minus 2m plus 5 equal to 0. And it's a non-factorizable factor. So by using the formula, the roots will be 1 plus or minus 2i. It is an imaginary and distinct root. Therefore, CF is e power alpha x into c1 cos beta x plus c2 sin beta x, where alpha is 1 and beta is 2. Thereby we will get the CF. To proceed to find pi, pi is 1 by d square minus 2d plus 5 into sin 3x. Sin 3x means to find pi we should use case 2. So we should put d square equal to minus m square. Please note it is only minus m square, not minus m whole square. Okay, so we will get minus 3 square. So that is minus 9. So only for d square we have to substitute, and that will give us 1 by minus 4 minus 2d. So minus 2 is common, that will give 1 by minus 2 into d plus 2 sin 3x. But again we have to convert d to d square. Therefore, whenever we have trigonometric functions, that is when we are using case 2, we will rationalize. So these are the things to keep in mind. That gives us 1 by d plus 2. Rationalizing means multiplying and dividing by its conjugate. Conjugate of d plus 2 is d minus 2. Multiply and divide by d minus 2. That gives us d square in the denominator. So again substitute for d square as minus m square. That is minus 3 square, that is minus 9. And minus 9 minus 4 is minus 13 into 2 minus 26. Minus 1 by minus 26 is 1 by 26. In the numerator we are left with d minus 2 into sine 3x. That is d into sine 3x is 3 cos 3x minus 2 sine 3x into 1 by 26. That is the particular integral. Hence write the solution as CF plus PI. Hence the solution. Now going on with the next problem. D cube y by dx cube plus 8y equal to x power 4 plus 2x plus 1. Right hand side is a polynomial. Now what is the solution? D cube plus 8 into y equal to x. So we are first writing it in the operator notation, equal to the right hand side. Then write the auxiliary equation m cube plus 8 equal to 0. It is in the form of m cube plus 2 cube equal to 0. That is a cube plus b cube formula. A plus b into a square minus ab plus b square equal to 0. So m plus 2 equal to 0 gives us m equal to minus 2. M square minus 2m plus 4 equal to 0 is non-factorizable. Hence using the formula and simplifying, m is equal to 1 plus or minus I root 3. Therefore, m is equal to minus 2 and 1 plus or minus I root 3. So, minus 2 is real and distinct. Use case 1 of CF. C1 e power minus 2x plus e power x into C2 cos root 3x. So, 1 plus or minus I root 3, case 3 of CF is used and CF is written. Now, going on with particular integral, we can see that the right hand side is a polynomial. So, since it is a polynomial, we have to write it in the form of 1 by f of d should be written as f of d inverse. So, we are taking the constant out and thereby it will be written as 1 plus d cube by 8. Okay. So, when it goes to the numerator, 1 plus d cube by 8 inverse into the polynomial. So, 1 by 8. Now, this is in the form of 1 plus d inverse. So, I had given the formulae. So, use that expansion 1 minus d plus d square minus d cube etc. In this case, d is d cube by 8. Substitute and expand and multiply by this polynomial given. So, 1 into the polynomial is the polynomial itself. So, we will get 1 by 8 into x power 4 plus 2x plus 1 minus d 1 by 8 into d cube, that is third derivative of x cube, x power 4 plus 2x plus 1, third derivative is 24x. The others are all 0. That is 6th derivative, 9th derivative are